Very good evening, those who are present here. I just want to introduce by myself. Myself, Dr. Syed Ismail. I'm working as an assistant professor in SRM Institute of Science and Technology in India. So, we already know today we are here for a seminar title called Secure IIoT, Industrial IoT Trust Framework using Fuzzy Logic and Blockchain. So the thing is here, as our title implies that we are using three major things. One is IIoT, and second part is fuzzy logic, and third part is blockchain. So usually we've gone through several papers. There might we can find either IIoT with fuzzy or IIoT with blockchain. But this new approach, what we did is we integrate both fuzzy logic as well as blockchain into our IIoT framework. So this is our title. So we just go and see what are all the things which we did. So this is outline of our presentation today. My agenda is starts with introduction and objective, novelty, and what originality in this methodology, what methodology we are using, and salient features of our project, and what are all the preliminary research we did, and deliverables, results, outcomes, and conclusion. So these are all the agendas today we are going to discuss. So we start with introduction. What is IIoT? It means we are saying industrial IoT. It's a major role nowadays. We people are built several infrastructure with machines kind of things. But if anything happens into my machines or any fault occurs in the machines, we used to change the entire set or entire part. But how can we reduce these kind of things, and how can we identify the issues with the help of sensors, so that we are going for this industrial IoT? It refers to the interconnected sensors and instruments and other devices, all network together with industrial applications. So mainly it is including of manufacturing and energy management. So basically we are using IIoT in the industry for energy efficient purpose. And why we include this blockchain into it? So blockchain shows promising potential. I think most of you are aware of blockchain. So it's a immutable storage and applications with the redundancy and for encryption. So these are all the major part we can secure. That's what we incorporate with blockchain technology. And it's a normal basic things of blockchain, what actually this represents. So here we have a diagram of our research. So we have one circle with industrial IoT and one circle with blockchain. And this platform, actually this blockchain based industrial IoT platform, we enhance with fuzzy. So we start with blockchain technology produces a structure of data with inherent security qualities. So if I talk about security, so blockchain is already with some secure concern, because each and every blocks which we created with some hash values, and it is already secured, so that what we are going for this blockchain, and it is peer-to-peer distributed network, and we can use it to create a standard security protocol in this. And mainly we are focusing on this cryptography, and second one is decentralization, because if we take blockchain, it is a decentralization one, and with the help of consensus mechanism we are ensure the trust in transactions. So whenever we are doing any transactions or thing, we can ensure the trust. So all transaction within the blocks are validated. So that is the main thing we are going for this blockchain with the consensus mechanism. And we are talking about fuzzy. What is the main inference of this? The fuzzy inference is used in a wide range of applications, because if you want a result with high range or if I want to detect any malicious with low range, it is very easily we can predict with the help of a fuzzy system. So that's what we are going for this, and it's including of control systems, decision making systems, and pattern recognition systems, and some imprecision or inheritance in the data. So the second point, by allowing for this representation of manipulation, here we are doing some uh, uh, we are doing with the data in the fuzzy system. For what the main thing is, it's a powerful tool for dealing with the complex real-time problems. So next, move on to our objective. What is the objective of this project? To ensure trustworthiness in handling the vast amount of data, because if I take industry, means industry IoT means we have a several data, and that vast data we need to secure, and we need to find out whether which data is yeah, energy efficient data and which one is the malicious data. So that also we have to find, and we are going to prevent unauthorized tampering of stored information in the local database, because if we talk about security, uh, the authorized person or any authorized people also one of the major concern in this. And third one is integrating the fuzzy inference techniques into the consensus mechanism to identify the malicious nodes. So for that, this one we are doing. And what are all the novelties? So because we have several papers about IIoT, several papers about blockchain, and several papers about fuzzy also. So what is the novelty in this? So the project introduces a novel combination of blockchain and fuzzy logic for addressing. So we are combination of blockchain and fuzzy logic, and it addresses the key challenges. So what are all the key challenges I have? Trust, data privacy, and efficiency in IIoT networks. And second one, so fuzzy logic for node selection. This is the second main thing. Even if I have several nodes, they are generating several values. In that, which values we can take and which value we cannot take, because in case if a valid data, we can take it with the help of fuzzy. In case if it is not valid data, we consider as a malicious data, and it is going to reject. And based on the higher efficiency of data, which node we are predicting from the fuzzy, that node we are saying as a energy efficiency, the it produces the energy efficiency. So the integration of blockchain ensures the secure data transaction while reducing the average energy consumption through optimized node selection, provide a unique solution compared to previous approaches. So originality, because whenever we used to talk about novelty, the originality is also same, because here we are integrated with fuzzy and blockchain, and because of this blockchain we are saying this secure trust mechanism, and based on the fuzzy we are detecting the malicious data and energy efficient data with the help of fuzzy. So this is a very simple diagram flow of our work. So we start with device initialization. So in initialization, we are connect all the IoT devices, and initialize the coordinated device. So here we have one CID. It is a coordinated device. So if we have several nodes, in that several nodes, only one node acts as a coordinator node. And second one is we are going to trust establishment because of this blockchain. And third one, as a part of blockchain, we have data encryption and real-time security monitoring and all it's happened. And that said, we have a fuzzy techniques which we are using. It's use anomaly detection, identify unauthorized devices, analyze behavior patterns, and attack mitigation is going to happen, and imperial security metric analysis. So this is the basic flow of this entire work. And methodology, what methodology we are using? First, we are here with fuzzy logic design. It define variables, membership functions, and fuzzy rules. So we have several fuzzy rules in the MATLAB itself, so that we are get into this MATLAB model and interpret the behavior and decision making process of the industrial IoT. So if we go with MATLAB in fuzzy, so we can identify what are all the nodes which is malicious or which is perfect node, that and all we can easily take a report from this fuzzy, so that we are having this fuzzy thing. And the integration of blockchain, all the data which we are receiving from the IoT, so that data we are going to integrate with the blockchain. And so this system flow implementation, how it's going to be work is, we have several IDs which generate from the nodes. So that IDs itself, we have a coordinate ID, and malicious data also will be there. So monitoring ID also will be there. So this is what our system flow implementation. And here we have a one architecture diagram. So if that flow, the same thing which is going to be happen in the diagram also. So we starts with the configuring of network. We are going to send the IDs, like what are all the data which we are receiving from the IIoT, we are sending it to the module. So here we have three modules. So first one is tracking proficiency, second one is authenticity, and third one is endurance period. So these three major things which we are going to focus on this work. And from this, what we are going to do is, after receiving these data, we just put it in the blockchain table. So whenever we are going to put it in blockchain table, that we know it creates the timestamp. So everything it will be generated by their system itself. After that, what we are doing is, we are move on to the fuzzy inference. So once we send to the fuzzy inference, what it will check is, it will check whether the report, the legitimacy report. So legitimacy report is nothing but which data is the perfect data and which data is the malicious data. So that is what we are going to take from the final report. So this report we can easily get with the help of fuzzy, which incorporate with the MATLAB. So this is the basic algorithm which we did. So how we are going to that find out the MC monitoring capability. It's nothing but we have a PDR, it's a packet delivery ratio, and E is a residual energy, and activeness measures transmission frequency. So here we have trust factor. So based on the trust factor and survival time, we are going to find out the node whether which is strong, energy efficient or not. So that is what we are going to see in the next one. And how my algorithm is going to be work is, so input we are giving n number of IDs in the network. Among that IDs, one coordinating ID is elected, and we have several n number of monitoring devices also be there. So in that, only one ID is as a coordinating ID, maybe that may be changed based on the I ratio. And if normal ID, if ID is normal, then we have to find out the trust factor and monitoring, then finally blockchain record. So if the information of each record corresponding to the corresponding ID, it means all IDs, all information of the each record is belongs to the CID, is stored in the database with current and previous hashes. Else, if ID is elected as MD, so then my output ID is either legitimate or malicious. So it is the final stage of the report. Either if it is strong, it's legitimate, it is a perfect one. If it is malicious, then we drop out the particular node. So this is what algorithm is going to work. And what are all the salient features? See, if I take blockchain, if I take fuzzy, if I take IIoT, so what are the salient features in this? So blockchain is for data security. It provides granular access control to ensure data privacy and transparency, because we all know it's a transparent and decentralized, so that blockchain. And fuzzy logic, that also it's a reliable nodes participate in transaction. Here the what is the mutual thing about fuzzy and blockchain? Both are immutable here. And third one is secure and transparent environment. So as of we know that blockchain is usually transparent, so that is what we are mentioned. And in simulation part we use MATLAB, because it's very easy, as well as we can get the report as we expect. So that is what. And finally what we find is it's a energy efficiency. The fuzzy based systems reduces average energy consumption per node, so ensuring more sustainable for the IoT operations. So these are the salient features of the project. And before entering into this project, what are all the preliminary research we did? So as of all researchers will do the same thing which we did. First we went with the literature review. So based on that we identify the technology, what are all the methods they used. And based on that literature survey, literature review, we went to the problem space. So it identifies the challenges include the malicious uh, identify the malicious devices and compromising the network's performance and security vulnerability. Because of this malicious device, it it will extract, or it will produce the unwanted data also. So the perfect data also get waste, so that we do this thing. And what are all the gaps in existing solution? So current approaches to trust and efficiency lack the flexibility and adaptability required in the IoT. So sorry for the issues. So next, based on this gap in existing solutions, what we found as current approaches to trust and efficiency lack of flexibility and adaptability required in IIoT environments. So finally, we are talking about technology exploration. It investigated the applicability of blockchain for secure transaction and fuzzy logic for adaptable decision making in IIoT infrastructures. So here we have deliverables. So as we said, the same thing, functional blockchain, fuzzy logic systems, and we have a MATLAB simulation results, and how we are going to do the security mechanisms, and finally we are generating the technical report. So first we start with because here we have some mathematical formula for find out the first initial stage. So first we are going to find out the tracking proficiency. So because we need to find out the tracking proficiency, endurance period and all. So first we start with the tracking proficiency. It's like represents how accurately and consistently a device monitors, because when we send n number of IDs into the module, we have to check whether which node is actively it's working, or which node is absent. So we have to check whether it is accuracy and consistently a device monitors, and it assign paired and reports their activities in the IIoT network. And if it is high tracking proficiency, means the node is behaving correctly. So that is what we have to highlight here, because if high tracking proficiency means my node is correct, it behaving like a correct one. If it is not in a high tracking proficiency, means then it is not a valid, or it is not a perfect node. So here we have a formula for this. It's a simple formula: number of correctly tracked activities divided by total assigned activities. It's nothing but total assigned activity means the nodes which we are sending as an input. So here we have a value. So because each and every thing, we have some limit we have to set. Based on that, we can calculate. So here tracking proficiency value, we mentioned 0.8 to 1 and 0.5 to 0.8, and less than 0.5 it's not reliable, or we can consider as a malicious device. So if it is high, it means my tracking proficiency value is 0.8 to 1, means we can say it's a excellent device tracking and its fuzzy level is high. If it is between 0.5 to 8, means we can say it's a moderate, and it's a medium one. So based on this thing, we generate, and before that I'll tell you, here we have tested with 100 datas, and this data we got from Airtel network. It's a famous network in India. So here because we are not supposed to test all the 100 data, so that what we did is we segregate like 10 rounds with 10 IoT. So it means 100 values we tested here. So for each and every thing we had a value, like it starts from 0.912 and it's end with 0.64. So we have a value based on the previous papers, we have a threshold value of 0.5. So that is what they consider as a maximum thing. But here we are not go until 0.5. So we are here at 0.64 itself. So how we tested this, and how we got this, and what is the procedure of this table? So this table represents the tracking proficiency in IoT nodes. So we start from IoT 1 to IoT 10. Each one is having of 10 rounds. So it means hundreds of data. The value indicate the performance or accuracy of each IoT device. So here you can see my initially the proficiency values are high. So what I said is, if it is 0.8 to 1 means it's high performance, so it's a perfect working value. So around 0.9, it's a strong tracking stability, and it's gradually declined up to 0.64, and even it's a 0.64, we cannot say it's a malicious node, because here if it is 0. Up to 0.8 we consider as a medium value, so that still it's 0.64. So this is the perfect one which we got the result. And second one is, first one we find out the tracking proficiency, and second one we have to find out the endurance period. So what is the endurance period is, whenever this node work, we need to find out the operational sustainability, because whenever we start, the high proficiency will be there, after a second or after a minute it goes down. So but we need to check whether that data is sustainable. So that is what we are calculating, this endurance period, to check the operational sustainability, how long it remains the functional and participates without failure. So that is also one important. So how we are calculating this? So it's nothing but just uptime divided by we are uptime plus downtime also. Here also we have the same calculation. If it is 0.8 to 1 means it's an excellent endurance, the fuzzy level is high, and 0.5 to 0.8 it's average endurance, but it is not worst case, but it's a medium one. If it is less than 0.5, we are saying it's a frequently failing device, because whenever the started time it will like 0.9 and all, but slightly it will get reduced. If it goes 0.5, then we are considering as a poor. So here you can see all our endurance period of device is 1. So here the thing is, either it will be 0 or it will be 1. So for all our round it's like 1. So here you can see we each node consistency maintains a value of 1 and indicating stable and uninterrupted performance. So what we said, whenever the starting time it will be high, after that it slow down and it get reduced. But here the thing is, the endurance period it's a sustainable, so the progress is sustainable, and its operation is also sustainable, so that it's not go below the one level. So if it goes below one level, then we can say that it's not a operational sustainable. So that is what here. So it's a high endurance and reliability for the continuous operation. And third part is accurate authenticity. So authenticity is, we well know what is authenticity is. It's a truthfulness and consistency of the data. So basically authenticity means, we used to say it's a kind of secure mechanism. So here it's a truthfulness and consistency of the data transmitted in the device compared to expected, because we have a mind to get some data which we expect, but in some cases maybe data tampering and also may happen. So we have to check whether any fault, data injection attacks, or any data tampering may be occurred there. So if it happens, so how we can record this? So here if it values is 0.9 to 1 means the data is authentic and it's very high level. 0.6 to 0.9, it's a minor deviations maybe happen because of network, because we can maybe something may happen, so that also medium. And if it is less than 0.6, like it's, if it is low, then it's a tampered data. That is what we classified here. Here you can see same, we tested the data, and here maximum we got 0.50, starts with 0.9 and gradually decrease up to 0.5. So if it goes below this thing means, then we can say it's maybe some malicious may happen. Sorry, so malicious maybe happen. So finally we are going to send all those data into my blockchain. So once we push all the data into the blockchain, then they generate the values with the each blocks. So once created, here we highlighted the maximum values which occurred in the blocks. So finally we found that if it is high, the values are high, we can say it's a legitimate, because it's a perfect one to go with that. If it is, if the value is less, either maybe it's legitimate or malicious. Okay, so here you can see the right side one. So if it is high value, for example 2.49, we can say it's a legitimate, so it's a perfect node, we can say. If less, like 2.34692 means, we can say either it's a legitimate or malicious node, because we don't know which one is legitimate or which one is malicious. So that if wherever we highlighted, we can conformly we can say it's a legitimate value, because the range, the value is high. Once we can check with the graph also, because anyhow we are going to get the graph value, because we are inserting into the MATLAB in the fuzzy. So that time we are going to check the values. So endurance period, you can see all 1, because already we took the endurance period value, and tracking proficiency also we took. So here why this IoT device 5, IoT device 25? Because we have 100, in that we took some several. For example, it's a 5, 25, we just tested the randomly, and 60 and 85. So these are all the based on the values we plot the graph. And then how we got this graph? So that is what here we worked on the system, and we got the we gave the input value and got the graph which we plotted here. So these are all the sample picture we took. And how this parameters work, how this fuzzy rule is work, because what are all the input parameters we are giving to plot this graph. First one is tracking proficiency, what I said, and second one endurance period, and third one authenticity. Based on these three, we are got the report whether it is legitimate or malicious. So fuzzy rule, how it works: if if TP is high and EP is also high and authenticity is also high, then legitimacy is high. If authenticity is low, whatever, even TP is high and endurance is also high, but authenticity is low, all that legitimacy is also low, because the authenticity part is also main thing. And if TP is low or AU is low, then legitimacy is also low. So this is the fuzzy rule. This is also a system based one. So here I mentioned like tracking proficiency is low and authenticity is low, endurance period is also low, then blockchain weight is also low. So this is the comparison table. Based on this it will work. And finally, based on our previous papers and all, we set the threshold value, the maximum 0.5. Based on the existing papers we got 0.5, but as per our thing we got 0.4, because we not reach the threshold value. And these are all the outcomes based on our project: reduced energy consumption, it's improved security, enhanced trust, and it's a scalable. We can add several nodes, because I said it's a n number of nodes we can add, so that is what it's scalability. And it's an increased operational efficiency also, because whenever we check endurance period, we can check the operational consistency also. And I finally conclusion, it offers the comprehensive solution to critical challenges in industrial IoT networks, because nowadays industry is the main thing for energy, and also in IoT networks, by combining the strength of blockchain technology and fuzzy logic, and it not only enhances trust and transparency, but also provide energy efficient, secure, and reliable IoT operations. So this is what we did so far in the project. So in case if you have any doubts or any queries, kindly give us an input. We will go for further. Thank you.
Thank you for your talk. Let me switch the microphone to this one. Yeah, to this one. And now we proceed to Q&A session. Any questions in audience, or I'll enable chat, maybe online?
Maybe I can ask you questions. Thank you for the presentation.
Thank you.
Just give me like basic understanding what is IIoT and how is it different from like normal IoT infrastructure that you have at home, for example?
Okay, actually, the if we take IoT, means it's normal. We used to go for hardware setup and we generate the data and all. But if I go with IoT, means I can take some data from the direct industry part. So because based on the machines or based on the network devices, we generate the nodes values from the network. For example, if because we used to get from the Airtel network. So but normal IoT means we go with some sensors, and from hardware setup, based on that we will get the output nodes. But industry IoT means we can generate the data from their industry itself based on their sensors, and we get the data, then we test it. So that is what we happened here.
And like at what architecture level have you incorporated this thing?
It's a basic architecture, like, because here we are focusing on these three: tracking proficiency, authenticity, and endurance period. So that here we focused on this main thing. That's what, because we push all our IDs, all our nodes into these three. We are calculating these values, then we send to the blockchain, and finally we are getting the report with the fuzzy inference. So this is the basic architecture diagram of our
Though I mean, like you are checking if some IoT is malicious and all, like this is how is it generally getting at what blockchain level? Like is there
So that is yes, because that one we cannot check earlier, because after we are getting the report, legitimacy report, then only we can say this is malicious. If it is malicious, it will not consider to work. If it is legitimate, if it is a perfect node, then only it will work.
and this malicious node is getting written on the blockchain also.
Yes, it is get written.
And it is getting written as flag that this node is
Malicious. Yes, it will not further. It will not produce any like it's like the inactive.
But I mean, the calculations that you're doing to prove that it's malicious, and this is being kind of backed by from where? Like, is it happening at the consensus level? Like, what is the
Yes,
coordination?
it's happening in the block. It's in the consensus level. So that is what our final stage with.
And since the round was reducing, as the round increases, technically the round level, don't you think it would be more or less, and that will make it further malicious?
No, we'll see. Because we tested this, we set some value like below. If value goes, then only we are saying it's malicious. But ours is not reached the that much level.
Oh,
that is what.
And there was this, figure like there was a blue color mark.
Yes, because it's a high range value, so that we highlighted, because it's a perfect legitimate. It's a perfect node. That's what we highlighted for my reference.
And what determined that to be perfect?
Perfect means there is no malicious, because if the value is less, either may be malicious or it legitimate. If it is value is high, then it is perfect node, legitimate node.
And what type of tracking do we talk about usually? You mentioned tracking somewhere, right?
Yes, the first one. Yes.
Yeah, tracking proficiency.
So,
What tracking?
like, actually the tracking is nothing but it's accurate node. See, because whenever it starts, sometimes like it's a high value, then it goes to a direct low value. But here what we are saying, if it is accuracy and consistently, because it will not goes direct though. So that is what here we are tracking the proficiency of the
position tracking, is it? That I missed.
Which one?
The position tracking, like physical position tracking.
That node, that value of the node. Yes.
Tracking. So there is a value that should be tracked.
Yes.
Be within this range, for example.
Yes. This is the yes.
Okay.
Maybe let me extend the questions because I've also missed the motivation. So the story behind, so before blockchain, so you have a network of IoT devices for some industrial application, yes? They need to do some tasks or activities like measure something with the meters, temperature or gear position or whatever. Yes, something like that.
No, here we took the only nodes of mobile technology, but we planned for.
Okay, what do they measure in your particular example with that famous data set in India? I don't know the data set. What are they tracking or tracing?
They are tracking means how we are.
So you have data set.
Yes.
The table 10 rounds, 10 devices.
We have a data set. Yes.
They provide some information to the data center, or they
yes, whether that signal is low, whether the signal is perfect, or some crashes may happen in the signal. So that kind of data.
So they just communicate, transfer some information.
Yes, exactly.
So they route network
signal. Yes, exactly. Because whether it is strong or it's weak kind of things.
Okay, and why it fluctuates? Something changes in environment or devices are moving. Why does it change the signal?
Because see, here we took a sample of data and we tested based on the signal travels. Because if it is very low, means based on that we can go. But what we thought is it's a normal thing while transmitting the data. So this is will be happen like that we consider, because we cannot say this totally get damaged. We cannot predict that. so that if it is totally it's not in a stable way, then we can say this is a weak signal and this is we can drop. But if it is medium, or if it is in the level of medium, then we can say it's a somewhat okay. Then if it is strong, then we can say the signal is very strong, it can process or it can deliver.
Okay, so unstable signal, different tasks, and because of routing or whatever, we have priority routes and less priority routes, and that is our question. And you propose to flag all devices as malicious or fair, and malicious or fair are not in terms of their attackers or bad guys. The thing is that right now they have bad signal. They can't accomplish the task.
Yes, actually the thing is, because if we consider the each and every part, it's like very big, because we took only this three particular thing and we tested. So in future, if we go for next thing, means definitely we will incorporate in the next one, because as of now we consider these three and we did, but in future we plan to do the other stuff.
Okay, and so you flag somehow some devices and remove them from this routing problem, yes? From this routing task.
No, because if it happens, if it is very poor, means they used to remove. Because if it is malicious or if it is doesn't work, means definitely we have to go for change. But if it is okay, if it is if it is stable, or if it is above the average level, means then it is good. Like that we consider.
Okay, so you want to select only devices with the best signal right now to accomplish the task?
No, because what we receive the data, based on that data we just incorporate and we did. So in that there is no worst level of data. So maybe that Airtel network, maybe it's good network, I don't know, because we got whatever the data, it's a normal one, so that we test.
Okay, and you compared the results with to the system without blockchain and fuzzy logic, or what?
No, we because in previous thing we have separate, like either with fuzzy or with blockchain. So we compare with fuzzy and with the values. Based on that, they mention like values 0.5. It's a maximum value they predicted before based on the previous papers. But here what we got the result is 0.4 based on the value. So that we mentioned.
But why is it more energy efficient? You do not assign tasks for some devices which highly likely will fail, or you just switch them off?
Actually, we are not tested that particular thing. Maybe in future we have a plan.
Yeah, but you have a plot with energy efficiency per round, and you win.
Where?
Some plot with 0.5 and 0.4
Yes,
energy efficiency per
yes,
round.
actually,
No, I think later.
only these three.
No, energy efficiency. Don't you have it?
Only these two slides.
No, some other slide. With a single plot on a slide, you had a slide with some energy efficiency.
Blue and orange one, right?
Yeah, something.
Last one, yes.
This
one.
Yes.
Yeah. So it is threshold. It is not.
Yes.
But consumption of energy per round in the title, is it consumption of energy?
Yes, why we said it's energy means because the maximum value we consider as a legitimate, then we are saying this as a perfect node. So if this is a high performance node, then we consider this as a efficient, and then only we are saying this as a best one.
Okay. I'm still have a kind of problem with like setup and motivation. No, not with motivation, with setup. But okay. Any other questions?
Yes, and when you're talking about the values getting written to the blockchain, have you done this already, or is it only theoretical part right now? No, the value getting processed to the blockchain, right? The value will go to the blockchain. Have you done this thing already, or like it is only like a theoretical future work which will be implemented?
No, this one we tested and only we put this.
How did it happen?
Here we created a blockchain
How did you do it in blockchain? It is doable.
Yes,
Okay.
it's done by wait,
Okay, fine.
I'll explain.
Go ahead.
Any other?
Yeah, about this fuzzy logic part. So you have a lot of thresholds and like simple sequential rules and some thresholds. So thresholds are not adaptive, yes. So they are hard coded. Am I right? The 0.9, 0.6.
Yes, actually, this is the value we set up, but the threshold value we fix maximum as a 0.
Yeah. So yeah, we were talking about what? About thresholds and statistics. Yeah. And so what is what? So sometimes you have low signal because of weather or like conditions here and there, and 0.6 is a big value. But sometimes the weather is clear and the environment is open, and 0.6, let's say, is very low. So all the devices have a high value.
Yes, like that, because we have the value is it's a general value for threshold is 0.5 we fixed, but if it is signal is because of sound and all means, what we can say is we cannot understand what we are seeing in that particular because of noise and all. So it even if it travels, that we cannot consider as a good one, because if it is not in a proper way, then we cannot say we have to disconnect or we have to avoid that. That is what we are saying. So if it is a proper way, then only we can consider that.
Okay, let's thank the speaker.
Thank you very much.
Research.
Thank you so much for your patience and for your time.